Yes, welcome back. The next one we have heating effect of an electric current, that is energy. Heating effect of an electric current, energy, right? It gives some heat. That's we are saying that energy. Energy is heat is one form of energy, right? Yes. From that we are going to detail about Joule's law of heating. How much heat is produced while passing current, right? As in that you have a fan at home or you have fan at your school. Initially it was not operated. You touch that fan, you did not feel like heat. After some time you are going to switch on and continuously it is going to working and switch off the fan after 3 hours. Now you are going to touch, don't touch that, but you are going to nearby, you can feel the heat. Why? In the sense, continuously the current is passing through that equipments, right? So it gives some heating effect. That heating effect is called Joule's law of heating. Okay. Heating effect of an electric current. So we are going to see about the electrical energy, heat energy we are going to see. Right. Consider we have one circuit. In the circuit we have a battery, we have a key, and we have the resistance of resistor R. Across it gives a potential difference V, and we have one ammeter. This is connected in series and connected to key, and then key is connected to the negative terminal of the battery. And here I mentioned the current is I. In this circuit the current is passing, current is I, and the resistor of resistance is R, and the potential difference across this R is V. And Q charges are flows at a time T, right? The charges are moving from here to here, right? So it takes the time T. Then how we are saying that work done? As we know that work done is equal to V into Q, right? The voltage into charge. So work done is equal to V into Q. Okay. And here we are going to calculate energy. In lower classes we studied the energy is equal to work done, right? For that symbol I have written as E. Energy is equal to work done. What is the work done? We have wrote VQ, right? So VQ is the work done, which is equal to energy. As we studied in the previous case, electric power is the rate at which the electric energy is consumed or dissipated, right? So energy by time will give power. So power, capital P is equal to energy by time. What is energy? VQ divided by T. And what is Q by T? As we know that rate of flow of charge carrier gives current. So we know that current I is equal to Q by T. Using this equation, we can modify this equation, right? So power is equal to VA. This is the definition for power as we saw in the last, right? So P is equal to the product of voltage into current, right? That is equation number 4. And steady current flows in that circuit, right? Here the steady current flows in that circuit, right? Once it reaches through this resistor, what will happen? It produces some heat. So that heat, I can say that energy. Yes, heat is one form of energy. So the symbol is H. H is equal to voltage into current into time. Why we need to do like that? Because VI is called power. So what I have written here, power is equal to energy by time. Therefore energy we can written as power into time. So power is VI into time, that will give energy. So H is equal to VI into T. VA is power, power into time, that will give energy from that equation. So according to Ohm's law, we know that V is equal to IR. So instead of V, I am going to substitute as IR. So IR into I into T. Therefore I can write H is equal to I square RT. Right? Therefore the heat produced in a circuit is directly proportional to square of the current, resistance and time. The heat which produced in an electric circuit or electrical component, that mainly depends upon the square of the current I square, the resistance of resistor R, and the time flow T, right? So these three parameters is depending by this heat energy, and this is called, we are saying that this equation called as Joule's law of heating. H is equal to I square RT, and this is important question, 2-mark question they can ask, even for they may ask for 3-mark question or subdivision question in part 5-mark question also, right? And from that equation, energy divided by time, that will give power, right? So power is equal to h by t, that is equal to I square r. Yes. So this is the another form of power, that is equal to P is equal to h by t, r which is equal to I square by r. I square by r already we have seen. Apart from that, P is equal to h by t. Okay. Where we are using these heating devices? Can you? Yes. If you are using iron box, or if you are using induction, if you are using water heater, okay, these are all, we are applying this Joule's law of heating in that appliances. Then what about the inside the material? Either it should be a conductor or alloys or whatever else. Yes, alloys. Why we need to go for alloys? Because alloys do not oxidize at high temperature, because we are the heat is produced here, heat produced in the sense temperature is rises. So we need to go for alloys, not metals. Alloys do not oxidize at high temperature. That's why we are using in electrical devices like toaster, everything, oven, everything we are going to use alloys. Then what is the use of metals? Two transmissions, copper and aluminiums. They are very good conductors. That's why they are used in transmission purpose. And what about tungsten? Tungsten filament. You have seen the tungsten filament, right? The tungsten filament which is used for bulb to produce light. Yes, due to its high resistance, it produces light. Due to that high temperature and passing through the current, due to that heat, the heat is converted into light form, that we are getting the tungsten as used for bulb. So these are all the application part of Joule's law of heating. Right? I hope you understand well. Thank you. See you in the next video.